Hello everyone. I am going to be attempting all the the section exercises in this Calculus for Scientists and Engineers. It's by Briggs, Coran, and Gillett. Hopefully this doesn't cut me as much as a Gillette does. And it is the single variable. Excuse me, but I can be very punny, so excuse my puns. I have told my parents that instead of giving me my name, they should have given me the name Rapunzel. Okay, that was awkward. Anyways, I'm going to start off with section 4.8. The reason why I'm doing this video is to educate everybody out there in a calculus. Well, not more so educate, but more so educating myself, because I'll be able to rewatch these videos, and hopefully when I rewatch them I'll see what kind of problems I'll be facing. And I know the section exercises in this book can be intimidating, especially since now that you know that it's kind of like once you learn the lesson, which is like the basics, okay, now apply it to the applications. And I know for the most part, hopefully this will be helpful for some of you people out there, especially since for computer science majors out there, I know for now you might not see calculus as, the benefit for your major, but hopefully it will change your life around. No, I'm just kidding. So I'm going to start off with section 4.8 and let's get to it. Now, as I said, I'm only going to do the math problems, so I'm going to avoid the review questions because you can just reread it in the section over there and figure out the answer for yourselves. So for now, I am only going to do formulating Newton's method, not the section, but hopefully I'll upload. I don't know how I'm going to upload, but hopefully I'll get it to maybe a question per video. So for question 5, it'll be one video. Question 6 will be another. Hopefully, I'll be able to put all this in a playlist so you can just follow along with me in the book. Now, as I said, it is beneficial to follow along with me and see how this goes. And hopefully you'll be able to get the hang of doing Newton's method. I know not that many people understand calculus, so hopefully this will bridge a gap between understanding and not understanding. I will also try to attempt the applications. If I am wrong in any way, please let me know in the comments below, and I will try to respond as much as I can. So if you have any questions about Newton's method, I could try to answer them. In no way I'm an expert, I'm just a regular student. So let's get started with question 5. Oops, wrong questions. Okay, if I get the focus right, there we go. So for question 5, f of x is equals to x squared minus 6, and our initial x is equals to 3. I have it written down over here. Don't mind the stuff in the background. I already have it written down, and for the most part, I did the beginning before I started this video. So our f of x, when you're given this problem, f of x is equals to x squared minus 6. There we go, much better. And our initial x is 3. Now they give us the initial x because if had they not done that, we would probably have to guess our own x. And as much as I love math, I don't have time for guessing, especially since it's all by luck. So if you chose 3, fine. But if you chose anywhere from like anything higher, then you probably have to keep guessing and guessing and guessing. So we are given, f of x. So what you're going to do first is take the derivative of f of x. So our derivative of f of x, f prime of x, is equals to, this shouldn't throw you off. This is just another way of me writing the derivative. So taking the derivative of whatever is in the parentheses. So if you want to feel smart on test day, you can write this down, but I don't know, depending how picky your professors can be. So this is taking the derivative of d over dx. So when we do the subtraction, it's going to be simple because all we have to do is just take the derivative of each term. So taking the derivative of each term, our derivative of x squared is equal to 2x. And then once you're done with that, you're going to take the derivative of 6. Well, as we all know, the derivative of any number is just 0. So that's the simple part. So here we have over here our f prime of x is equals to 2x minus 0. But since anything subtracted by 0 is basically saying 2x, we're just going to leave it at 2x so we don't confuse ourselves. This is why you write in pencil and not in pen. Newton's method, Newton's formula is right over here. It is in your book. It's on page 258. Hopefully that'll help you. So in the book it says x sub n plus 1 is equals to x sub n minus f of x sub n. I wrote it down. It's really small, but there's the n right there. And f prime of x sub n. And wherever you're going to see this n here is just basically taking your initial one. Your initial, what's given to you in the problem. So you're given initial approximation. So our n is going to be 0. That's what we're going to start off with because they gave it to us. So wherever you see an n, you're just going to put a 0 there. There we're going to have x sub 0 plus 1 because for this problem we have to figure out x sub 1 and x sub 2. X sub 0 and plus 1 is equals to x sub 0 minus f of x sub 0 over x prime of x sub 1. X sub 0. Oh gosh, I'm nervous. Alrighty, so what we're going to do, and I'm sorry, but I'm going to try to attempt to say so less often. We already know what our f of x is, so let's bring it down here, minus, x sub n, well, more like sub 0 squared. I'm going to put this in parentheses so it doesn't look like a chemical equation over here. Minus that over our f prime of x, which we already figured out, which is 2x. So 2 x sub 0. This is all, so of course 0 plus 1, that's the easy part, x sub 1. Therefore, we're going to find our x sub 1. X sub 1 is equals x sub 0. Well, we know what sub 0 is, which is a 3, minus, 3 squared. So the reason why I put 3 here is because we already know what x sub 0 is. It's 3, because it's given to us. So we put 3 here, squared, minus 6 over 2 x sub 0 again. So we're going to have a 3 here. Alrighty. So far we got through the easy part. So x sub 1 is equals to 3 minus 3 squared is 9 minus 6 is equals to 6. Alrighty, in this problem we're going to do is 9 minus 6. Well, actually, yeah, 9 minus 6 is equals to 3 over 6. I feel like something's wrong here. Let's go along with it. So 3 minus 3 over x. This is basically saying half. So this multiplied by 2, 6 over 2. 6 minus 1 is 5 over 2. And 5 over 2 is basically saying, excuse me, it's basically saying 2.5. So that is our x sub 1, which we found is equals to 2.5. If you have any helpful tips for me to help you guys understand, also comment that below. If not, well then I guess I'm doing my job. So what we're gonna do is, now that we found our x sub 1, we can go ahead and find our x sub 2. So x sub 2, okay, we already found 1, so we're gonna put a 1 here, plus 1 is equals to x sub 2, because we have to find x sub 2 when n is equals to 1. Excuse my language. This is a 1. Minus f of x sub 1 over f prime of x sub 1. There we go. This is our 2. That's why I got confused before. So our x sub 2 is equals to x sub 1. We already know what that is, which is 2.5. 2.5 minus, alrighty, so our f of x, let's put an x squared over here. This is our 1 minus 6. Our f prime of x, so our f prime of x is just 2x1. Since we already know what x sub 1 is, which is 2.5, let me put this in the corner so I don't confuse myself. X sub 1 is equals to 2.5. Alrighty, so I already know what x sub 1 is, which is 2.5. We're going to square that. Minus 6 to 2.5 minus 2.5. There we go. Is equals to x squared. 2.5 squared, that is just 6.25 minus 6, yeah. 2 times 2.5, excuse me, I have an itchy nose right now. That's just 5 minus 2.5. Alrighty, let me do our math. 6.25 minus 6, that's the easy part. That's just 0.25 over 5 minus 2.5. Alrighty, whew. Alrighty, now that we have this done, alrighty, let's do this part. This is just 0.05, 2.5. Oops, gotta get that down more. Is equals to 2.45. Therefore, this is how my professor does the therefore, but if you want to write it out, go ahead. Therefore, x sub 1 is equals to 2.5, and x sub 2 is equals to 2.45. Alrighty, in the next video, I will try to attempt question 6. Hopefully it won't take me this long. It's taken me long enough to do question 5. And see you in the next one.